All right, it is 11:30. Good morning, everybody. I'm going to start this little timer to give you guys time to work on this warm-up that we have here. So just 3 minutes, 2 problems. Let me know if you guys have questions, okay? Good morning. We're working on a warm-up right now. All right, guys, let's go over these warm-up questions and let's dive into the tangent ratio. And it's really exciting, guys. So remember last class we talked about how triangles are actually circles and circles are actually waves. So we're going to be starting that today. We're going to be talking about how triangles are actually circles and circles are actually waves, and it's really cool, and it's called trigonometry, and we're going to get that started today, and I'm really excited about it. All right, but before we get into the new stuff, let's talk about the stuff we did last time, and that was I'm frozen, right? Call me Elsa. You can go ahead here, and we are going to remember how to solve for x using Pythagorean theorem and using Pythagorean theorem to classify a triangle, right? So a couple of different ways of doing this. So for the first thing when doing Pythagorean theorem, right, we always want to identify the biggest angle and the biggest side, and they're always going to be across from each other. And that's what we're really going to be building onto this today, is this relationship between angles and the sides opposite of them. Okay, so we have this 90-degree angle, and then we have the 8 across from this. So this is my C, and then I have, and it doesn't matter which one's which, right? So I could call this A, I could call this B. It doesn't matter because we're going to be adding them. And when you add things, order doesn't matter. So I might write down I have 4 squared plus x squared,
and then equals, and then I have my c squared, which is 8.
So to solve these, right, I want to isolate the x term that I'm solving for. So to do this, and again, we're going to be seeing this quite a bit, I don't want to use my calculator or my brain until the very end, right? Doesn't that sound fun? Like I don't want my brain to be working harder than it needs to. I just want it to do it once, right?
So I want to get this x squared by itself, so I'm going to subtract 4 squared from both sides. Now, a very common mistake that people make is they say 8 minus 4, but it's not 8 minus 4. Remember, 8 squared means 8 times 8. This is 8 times 8 minus 4 times 4. We can't just go 8 minus 4, right? We're multiplying. So you can't simplify these down. So we're just going to leave it, right? So if you're trying to simplify them, your brain is working way too hard. Relax, just let it go. Just say, okay, x squared equals 8 squared minus 4 squared. Just leave it. Just let it be. Just be like, you know what? Didn't want to do it. Then we get to here and we say, hey, well, I have my x squared. So squared, the opposite of squared, just like the opposite of adding is subtracting. The opposite of squared is the square root. Okay, but we have to be careful when we undo a square with the square root, we're going to end up with 2 answers, right? A positive and a negative. Now, since we're dealing with the distance, we only look at the positive. So we don't have to do the plus or minus, right? So we can do x equals the square root of 8 squared minus 4 squared.
So we only want the positive, right? We don't need the negative.
So I'm going to turn this on. Let's do a little quadratic formula with my algebra kiddos. So I'm going to have the square root of 8 squared minus 4 squared.
Okay, and boom. So my calculator,
now my yellow calculator tells me the exact, right?
Now, remember, you can use wolframalpha.com to do this as well, right? So you can remember, you guys remember doing that last class, right? So we used wolframalpha.com. That will also do this, right? Or else you're going to get a decimal. So, and this would be 6.9, and then we'd round up, so 6.93, right?
So the exact answer is this, and that is approximately 6.93.
Okay, so we do value the exact answer more than we value the approximate. Okay, does anybody have questions about that before I move on to the second one? Anybody have questions about Wolfram Alpha, how to use that? And it's just Wolfram Alpha. Okay, Wolfram Alpha. That is like the ultimate of ultimate resources for math and science. It's like a math science Wikipedia. It's pretty cool stuff because you can do anything. You can almost program with it. If you had, well, you can program if you buy it, right? It's actually a software that you can buy. Okay. There used to be a joke in college. We always used to say, real math requires real technology, right? Like, who does real math in their head? All right, so no one's asking any questions.
So for this next one, we want to identify our longest side. So our longest side here is going to be 7, which means that these are going to be my A and my B. We're not going to do an equal here. We're going to compare, right? So I'm going to have 5 squared plus 6 squared, and then I have 7 squared. And what we're doing here is we're trying to figure out what kind of triangle it is, right? So we're not going to make judgment until the end. So if I do 7 squared, that's 49. And if I have 5 squared plus 6 squared, that's 61.
Okay, so then remember, all we care about is the hypotenuse, right? So my hypotenuse is the bigger one. We're really focused on that. So I'm looking, okay, is this one smaller or bigger or equal? Well, they're not equal, right? So I think 49 last time I checked is smaller than 61. So that means it's less. So the hypotenuse is less. So if it's less, then it's going to be, oh my gosh, so baller, right? It's going to be an acute. Yeah, that's right. You're baller. I appreciate it. Oh, your name isn't capitalized today. All right, so there we go. Those were our two warm-up problems. Does anybody have questions before we move on? We're doing brand new stuff today. So last class was a bit of a review. Ah, yeah. You know, you can always change your name. Here, I got you, homie. There you go. Now it's capitalized. All right, so today we're gonna be doing trigonometry. Oh, guys, I'm so excited. So today is our first look at trigonometry. Okay. So now I always think it's weird that we start with tangent, but you know, whatever. Okay. So we're going to be taking a look at trigonometry, and trigonometry is the math behind that connects right triangles with circles with waves. And if that doesn't get you excited, right? Because trigonometry really is the fundamentals of our universe. Oh my gosh, it is so cool. Now, if you guys are looking for more trigonometry, all we're going to be doing is like an introduction in geometry. You're going to do a little bit more of it in Algebra 2. And then when you get to pre-calc, you do a lot more of it. Okay. And then when you get to calculus, and it's just like everything is a wave. Well, not everything, but pretty dang cool. All right. So let's take a look at this. So we are going to be, if you're following along in the book, we're going to be in 9.4, and we're going to be doing the tangent ratio. And this is one of the ratios that connects triangles to circles. Now, again, this isn't the most important one. It actually turns out tangent is actually the combination of two other things, and we're going to learn about those two other things on Monday. Okay? So this, again, this is just a little intro. Okay? Just a little intro. And we're going to do more of the whole like triangle to circle to wave thing. We're going to do that on Monday. Okay? So I'm sorry, we're not going to do the super exciting stuff today. Okay? So right triangles are actually circles, okay? And waves are circles. They're all tied together, okay? So what we can do here, this is what's really exciting, guys. So first I want to draw a right triangle. Okay. So in this right triangle, this is 90 degrees, right? So we know then that if this is the biggest angle, then this side is the biggest. Okay, so the biggest angle with the biggest side. So if this angle right here is the smallest, then this is the smallest side. Oops. Okay, so notice this relationship between opposite angles. Okay, so the smallest angle has this relationship with the smallest side, and the middle one does as well. And I'm going to get into that just a little bit. Okay, and the reason is these angles are related to each other. Okay, so this is, let me show you what I mean. We're going to draw another one like here. So we're going to focus on angles. Okay, so this is 90 degrees, right? What do the angles, so here, let's go like this. Let's go A, B, and C. What do the angles in a triangle add up to? What number? What do the angles in a triangle add up to? 180. Okay, so we know angle A plus angle B plus angle C equals 180 degrees. I'm probably off the paper there. Sorry about that. Okay, so we know this. This is the triangle sum theorem. Okay, so we know angle A plus angle B plus angle C equals 180 degrees. So check this out. Are you guys ready? Now, I'm going to use a new symbol that you may or may not have seen. In angle A, I'm going to call this Greek letter theta. So if you guys want to see this a little bit bigger, this is theta. Okay, and that's the Greek letter theta. It's a circle with a belt. Okay, so it's a circle with a belt. Now, another Greek letter that we're going to use is a circle with a horizontal line that goes through it, and that is called theta. Oops, sorry, no it's not. It's called phi. I meant phi, and I misspoke. So it's phi, P-H-I. So theta and phi. Now, that's how you pronounce it if you're American, right? Which, here we are, we're in America, right? But if you're British, or if you go to Canada, you would pronounce this theta and phi, like fee, fi, fo, fum. Okay, so in America, in the United States, though, we say theta and phi. Yeah, make sure that you watch the YouTube video because you're missing quite a bit. Okay, so theta and phi. So let's say I call, and we use theta and phi to reference angles. So we're going to call this angle theta. Okay, so let's take a look at this equation. And what I'm going to do is I'm going to solve for angle B. So that is, I have theta plus angle B plus 90 equals 180 degrees. Okay, so I'm going to subtract 90 from both sides. Okay, so when I do that, I get theta plus angle B equals, well, 180 minus 90 is 90. Okay, my theta was really bad, wasn't it? It's like, come on, Kraft. Okay. Well, check this out. If I subtract theta from both sides, I get angle B equals 90 minus theta. And now what's really important about that, I can write that up here. This is 90 minus theta, right? That's that angle, 90 minus theta. And you might be like, why did we just do this? Stop. What are you doing? This isn't natural. No, this is really powerful. Notice the relationship between these two angles. If angle A changes, doesn't angle B change? That is, if we make angle A smaller, this side will get smaller. But then this angle will get bigger, and this side will get bigger. Whoa, they're related. And that's what today is all about, is this relationship. So again, look how angle A goes with side BC, right? There's that relationship with the angle to the side. So if angle A got smaller, this side would get smaller. Does that make sense? Are you guys with me that if angle A got smaller, that this side would get smaller, right? Because like we would be pinching this side down. Okay. But if theta gets smaller, well, now it's 90 minus a smaller number. So that's going to be a bigger number, right? So if angle A goes down, angle B goes up. So that means as angle A gets smaller and this side gets smaller, this angle gets bigger and this side gets bigger. They're directly related. And how are they related? Because the angles in a triangle add up to 180, and this one is always 90. So the only two things that are changing in the angles are angle A and angle B. We call those the acute angles. Okay, so this relationship is so special and important that we look at the ratio of these sides and say it's the tangent ratio. Oh my gosh. So that was a lot. That was a lot to take in, and it was a lot of me talking. So we're going to have to really clamp down and be like, what the heck is Kraft talking about? Right? So don't be afraid to ask questions what's going on. So that was it in a nutshell. And I know you guys are like, Kraft, what did you just do to us? How could you? Well, I am pretty cold-hearted. So let's break this down and take a look. So again, if angle A were to get smaller, this opposite side would get smaller. But then 90 minus a smaller angle means angle B gets bigger, this side gets bigger. So as one side changes, the other side changes too, right? So if this side got bigger, this side would get smaller. And if this sides get bigger, then this side would get smaller. Okay? So what there is there's this relationship between those sides and the angle. And that's what the tangent ratio is. It's that relationship. Okay? Now, you can imagine these angles, right, can be anything, right? Theta can be anything greater than 0 or less than 90. Okay? Now, if you think how many angles that can be, the answer is infinite. There's an infinite amount of angles between 0 and 90. So the only way to represent this ratio is to have it be its own function. So tangent is going to be a function, just like x squared or the square root of x. Those are functions, okay? So this is a new function. It's a function of angle and ratio of sides, okay? Gosh, that's a lot, right? But this is what's going on. So the tangent ratio okay, so we're going to look at this, is given a right triangle. So we're going to have to talk about naming here. Okay, I'm going to have some vocab here. So our theta for us is going to be our reference angle. Okay, so for us, theta is going to be our reference angle. And basically what reference angle means is how this angle sees the triangle. Okay, now notice if I put up here phi has a different view of the triangle. So for example, theta, right, looking at this triangle, sees this as the side furthest away. But phi sees this side as being the side furthest away. So we're going to talk about reference angle. So a reference angle is the angle we pick to look at the triangle. So the angle we pick to look at the triangle. Okay, so you have to start out with a reference point. And that's what a reference angle is. It's a reference point. Okay, so what we're going to do is just practice labeling this. Now, the first thing, always identify the hypotenuse first. Okay, always identify the hypotenuse first. How do we know which side is the hypotenuse? You find the 90-degree angle, and the side opposite is your hypotenuse. Okay, always identify your hypotenuse first. Then find the opposite side of your reference angle. Okay, so then we're going to find the opposite side of your reference angle. Okay, so if my reference angle here is theta, I want to find the side opposite. So the side opposite would be this. So again, using your reference angle, we're going to find the side opposite. Okay, so you find the hypotenuse first, then you find your opposite side second, and then last but not least, the last side is your adjacent side. So, oops, adjacent, I should say side. Okay, the last side is your adjacent side. Okay, so that would be right here. Okay, so I have my hypotenuse is across from my 90. The side furthest away from my reference angle is my opposite. And the one next to it is adjacent. Now, this is why you should never do adjacent first. It's confusing because adjacent means next to. So if you take a look at this angle theta, aren't there two sides that it's next to? That's why you do this one last. Okay, because if you start out with the adjacent one, you're probably going to make a mistake. Okay, do the hypotenuse first. Adjacent means adjacent to the reference angle and the 90. Okay, so adjacent is the angle, reference angle and the 90. So I always just do it because that's really confusing. I always just say, hey, find the hypotenuse, find the side furthest away, right? That's what opposite means. It means furthest away. And then the one that's left over is adjacent. Okay? Now, you don't need to write this down on yours, but this is where things get confusing. So I picked theta to be my reference angle. Well, what if I had picked phi? Well, then my opposite and my adjacent sides are going to switch. Because what side is opposite from phi? The one down here. Okay, and then this would be adjacent. Okay, so that's what we're going to practice just in a second, is naming the sides. Okay, so I really should have called this naming sides. Okay, so let's practice that. I'm going to give you guys a couple of triangles, and I want you to practice naming the sides. Okay, so we're going to have so I want you to name the sides. And then, so here's one. And then two, here's another one. So for both of those, I want you to name the sides. So you're going to name the hypotenuse first, then the opposite, and then the adjacent. Okay, and our reference angle, we're going to pick theta. Because in geometry, we usually call our reference angle theta, and we call the other angle phi. That's just, you can do whatever you want, but that's usually what I do. So take a second, and you're just going to, for both of these, identify your hypotenuse, your opposite, and your adjacent. Yeah, I'm going to put a little timer up just for, it's not for you, it's for me. I just want to, if I don't, then I can't remember how much time's gone by. And I just want you to take a minute to do this. It shouldn't take very long. Identify the hypotenuse, the opposite, and the adjacent. All right, so again, how do we do this? Find your 90 and do that first. So across from the 90 is your hypotenuse. Okay, that's your longest side. It's across from the 90. Then my reference angle is down here. So the side furthest away, that's my opposite. Okay, and then the side that's left over, that's my adjacent. Okay, so I have the side furthest from the 90 is my hypotenuse, the side furthest away is my opposite, and the side next to it is my adjacent. And guys, this is really important. If we can't do this, then all of trigonometry is lost. So again, we have this reference angle and we're naming the triangle through its perspective, right? It sees the triangle like this. And that's really important because it changes depending on what angle we pick. So let's say I pick this one. So again, I'm going to find the 90. The side furthest from that is the hypotenuse. Now, if you guys want to learn some shorthand, you can abbreviate that as hype, okay, but it is the hypotenuse. The side furthest away is OPP, right? So that is opposite. And then the leftover side is ADJ. Now, I just warn you because a lot of students, they start thinking this means adjective, right? Because that's the abbreviation for adjective. So just remember this means adjacent. Okay? So how are we doing, guys? Are we doing okay with labeling? Because labeling is the most important part. I know, right? You guys got this. You guys can do this. But we had to practice it because if you are making mistakes, then the rest of this won't make any sense. Okay? Okay. So remember how I was talking about how theta changes, right? Then this angle changes and these two sides are going to be the same. So the tangent ratio, how many times am I going to write this, right? The tangent ratio, it's tangent, and we abbreviate tangent as TAN. Tangent, we don't say tan, we say tangent of our reference angle equals, it is a ratio. So a ratio means fraction. It is the opposite side over the adjacent side. Okay, that is the tangent ratio. Okay, so it's tangent of your reference angle, right? So this is reference angle. And this is tangent. Okay, and then this is the sides of the triangle. So it's the opposite side over the adjacent side. So it's a function. And this function, get this, right, is how we're going to be solving for things. So first, let's do an example of this. Okay. So let's say we have a triangle. And we're going to label this triangle. So let's say we're going to call it S, T, and R. And we're going to label it. So 18, 82, and 80. Okay. I want you to tell me what tangent of angle S equals and what tangent of angle R equals, right? And remember, your answer is going to be a fraction, right? It's going to be a ratio. So what's tangent of S? So remember, tangent of S is going to be opposite over adjacent. And tangent of R is also going to be opposite over adjacent. But notice how S and R have two different perspectives. So some of you are going to be like, Kreft, I don't know what to do. And some of you are going to be able to do this right off the bat. It doesn't matter what camp you're in. Okay, but let's take a look at this triangle. So the first thing, as always, is across from the hypotenuse, across from the 90 is my hypotenuse. So if I am angle S, then this side down here is my opposite. And tangent of angle S would be the opposite side over the adjacent side. You guys see how that works? So tangent of S would be the opposite side over the adjacent side. We will simplify the fraction, but for right now, yes, you're going to simplify you can, and we're going to. Yes. But I don't want to focus on that right now. Does that make sense? And for simplifying fractions, Desmos or this calculator will do that for us. So, for example, if I do fraction, 80 divided by 18, oops. I can't do both, can I? Right, is 40/9. So that would be 40/9. Okay. Not the biggest of deals right now. Not the biggest of deals, but yes, you're right. You should always simplify if you can. Okay, but for right now, are people doing okay? Do you guys see how the opposite of S, right, angle S was 80 and the adjacent was 18? Okay, now when we switch reference angles and we go to R, the hypotenuse stays the same, but now what's opposite, right? The opposite of R is now 18. So this becomes 18 over 80.
okay, which would simplify down to 9/40. Okay, so we just did one together. So now I'm going to have you guys try one on your own. Okay, so I'm going to have you try one on your own. So for right now, it's just tangent of our reference angle equals this ratio. Okay, how are we doing for time? Okay, so let's do try on your own. I'm going to draw one more triangle. So we got B, C, A, and 36, and 39, and 15. I want you to find the tangent of angle A and the tangent of angle B. And this will always be the acute angles. You'll never take tangent of a 90-degree angle. So go ahead. I'm going to put up a minute here because we should just take a minute and find the ratios of the tangent of angle A and the ratio of tangent of angle B. Remember, it's opposite over adjacent. All right, hopefully you guys are doing good. No one's been asking any questions so far, so I'm hoping you guys are like, crap, like this has got to be harder than this, okay? So I'm looking at tangent of A. So A is my reference angle, so I'm looking at the triangle through the eyes of A. So again, it's always good to first find your hypotenuse. So my hypotenuse, right, is going to be across from my 90. That never changes, ever, okay? Your hypotenuse is your hypotenuse. So in terms of A, I want opposite first. So opposite of angle A is 15. And then adjacent to angle A is 36. Okay. So then opposite of angle B would be 36. And adjacent would be 15. Now you can simplify these, right? These simplify to 5/12 and 12/5. Okay. How are we doing, guys? Do we have any questions with that? So this is just the tangent ratio, right? This is just like, what is the ratio? It's comparing the opposite side. So yeah, and it's easy to get confused, guys. This is brand new stuff. I'm not going to expect you guys to be like, this is the, like that's why I'm teaching it and we're asking questions, okay? So the tangent is the ratio of opposite and adjacent sides according to our reference angle, right? So according to our reference angle. So if we change our reference angle, the opposite and adjacent sides change, right? So that's why it's the ratio of opposite to adjacent, but it depends on our reference angle. Okay. Now what we're going to find out is we can use this to find missing sides. And this is the really exciting part. Now we're going to do a little bit of algebra. Okay. Okay, so now we're going to do this to find missing lengths. So finding missing lengths. Finding missing sides with tangent. Okay, and you can make jokes about a tanned gentleman, right? Okay, so let's take a look at this and then I'll have you guys practice one. So let's say I have a right triangle. And let's say I label this A, B, C. And I'm going to have the sides be X and 11. And I'm going to have an angle that is 32 degrees.
All right. So again, first, label your sides. Oops. I'm always one letter ahead. Label your sides. Okay, that should be the first thing you do. So across from the 90 is my hypotenuse. This is going to be my reference angle. Now, I know some of you guys are like, well, why don't we pick C to be our reference angle? You absolutely can. Okay? You absolutely can pick C to be your reference angle. But we're not going to because that's too much. Okay? We'll get to that in more advance, okay? So we're going to pick the given angle to be our reference angle. So that means furthest away from it is the opposite, and that would be the adjacent. Okay, so the first thing you do is label your sides. Then, 2, write out your tangent equation. Okay, so we're going to write out our tangent equation. So that says that tangent of my reference angle equals the opposite side over my adjacent side. Okay. Now, again, guys, this isn't anything for you guys to memorize, okay? So people always think that like, oh, like this is trigonometry has different math. No, no, no. At this point, all the math you've ever learned in your entire life still works. Okay, we're not learning new math. You don't need to memorize how to solve these. It's just algebra. Okay, so then we're going to say here, we're going to say solve for x. That's all we're going to do. So taking a look at this, just like any algebra problem, do we want x on the bottom? Do we want x on the bottom? If we're solving for x, do we want x? No, we don't. So if it's divided by x, we do the opposite of that. Now, again, people always will get in trouble because they try to memorize steps. If you do that, you're going to have a bad time. So I get x tangent of 32 equals 11. Now, here's the next hard thing for people. Do you guys see this right here? This is a number. And I'll show it to you. So if you have a calculator, just make sure you're in degrees. So on the yellow calculators, it will say degrees. If you are on, let me add a layer here. If you are on Desmos, okay, if you are on Desmos, it will say degree right here in the middle of your calculator, right? If you click it, then it switches to rad. We want to be in degree for degrees, okay? So what you're going to do is if you just find on your calculator, there's a button that says tangents, and then you can type in 32 and see how tangent of 32 is this really ugly number. That's why we just keep it as tangent of 32 because no one wants to deal with this mess, okay? On Desmos, right, tangent is right here. I would write tangent of 32, close the parenthesis, and it shows, hey, it's a number. Okay, so these ratios are already programmed into calculators. So remember, tangent of 32 is just a number. So I'm going to propose this. If you have x times a number, how do we get rid of that number? What's the opposite of multiply? Divide. So we would divide both sides by tangent of 32. Okay, so people get all worked up. They're like, well, what do I do with tangent of 32? Tangent of 32 is a number. So you do what you would do with any number. If this was x times 7, you would divide both sides by 7. So it is tangent of 32. So you're just going to divide both sides by tangent of 32. So what do we end up with? We get x equals 11 divided by tangent of 32 degrees. So right now, this is calculator time. Okay, so you make sure you're in degrees. Here, I'm gonna make my Desmos calculator bigger. Here, if I move this over, there we go. Okay, calculator time. So what I'm gonna do is I'm gonna hit clear all here. Notice how I have a fraction. So I'm gonna hit the fraction button. I'm gonna have 11 on top, and then I'm gonna have tangent of 32 on the bottom, and boom, there's my answer. Okay, I get x is approximately 17.60. That's how long my side is. Now, if that's not cool, oh my gosh, guys, this is super cool. So if you're building something and you're like, I wonder how long that side is, make a right triangle, boom, now you know how long that side is. That's how cool this is. Okay? Because you can make, and I know you guys aren't sold on this yet, but we can make a right triangle out of anything, okay? All right. Does anybody have any questions about that? I do have to do one more example, and we'll see how much more time we have after that, okay? And remember, tomorrow's our practice time. So I know some of you guys are like, well, I really just want to practice. Tomorrow's our practice time. So, no, there is an exact answer. That's your exact. 11 over tangent of 32. Right? That's your exact answer. And so this is our approximate. So if you were building something, then you would round to whatever decimal you need. Right? This is irrational, so the answer will always be a decimal that goes on forever. And remember, irrational means, right, that I'm not going to be able to write it as a fraction. Okay, so it's this or this. Okay. All right, let's do one more example and see if we have any time for you guys to, let's close this window. Let's see if we have any time for you guys to do some practice before we leave today, okay? All right, so here's example 2. So again, don't memorize those math steps. Don't. It's just algebra, right? Because it's not always the same, okay? It's not always the same. So let's take a look at a different one. So I'm going to have a different triangle. So I'm going to call this one X, Y, and Z. I'm going to call this 25 degrees, this 90. I'm going to call this 12, and this X. Oops, I probably shouldn't call it X. Let's call it W. Okay, so we're going to solve for W. Okay. So again, going through this, I'm going to label first. So I'm going to find my 90. The side opposite from it is my hypotenuse. Furthest away from my reference angle is my opposite. And then next to it is my adjacent. Okay, so always label first. Always label first. Okay, then I'm going to write an equation. Okay, so tangent of my reference angle is going to equal the opposite side over my adjacent side. So notice how this one's different. Do you see how the W is on top? Right? That just happens. It's just the luck of the draw. It depends on what angle we're using, right? Okay. So the other one, the X was on the bottom. So again, don't memorize how to solve these. You're going to have a bad time because things are going to change what location they're in. So just treat this like you would an algebra problem. So I'm solving for W, but I want, over here is this 12. So if I'm solving for W, I don't want this 12 here. So I say, okay, this is W divided by 12. So I don't want that divide by 12. How do we undo division? How do we undo division? Multiply, right? So I'm going to multiply both sides by 12. And I get 12 times tangent of 25 equals W. And we have to remember, that's a number. Right? So this is our exact answer, 12 times tangent of 25. So I can just go to my calculator, and I can go 12 tangent of 25 degrees, and I get is approximately 5 point. Now, in this one, this is a really interesting one, right? If I round to the second decimal, I'm going to go to the right, and if it's 5 or higher, I round up. Well, what's 9 rounded up? That's 10, right? So 10, this becomes 5.60. Okay? And I'd still include the 0 because I rounded it to the second decimal place. Okay. All right. We just did our second problem. How are people feeling? Do you guys want to try one really quick? Let's try one really quick. So before you guys leave, let's try on your own. I'm just going to make a quickie. Okay, so let's say this is x. Let's say this is 7. And let's say this is 32 degrees. Okay, solve for x. And we don't have a lot of time, so I'm going to give you guys a minute and a half to do this. So if nothing else, set up the tangent ratio, right? Be able to set that up, know what side's my hypotenuse, what side's my opposite, my adjacent, be able to set it up, and then you're going to want to solve for x, right? Get x by itself and type that into a calculator. Okay, so let's take a look at this. So I have a minute so I can do this. So my hypotenuse is across from my 90, which makes this my opposite from 32 and this my adjacent to 32. So my equation would be tangent of 32 degrees equals the opposite over the adjacent, right? So this is opposite over adjacent. Okay, well, I don't want x to be on the bottom. So I'm going to multiply both sides by x. And so I get x times the tangent of 32 degrees equals 7. Well, I don't want this with x. So it's x times this. So the opposite of multiply is divide. So I'm going to divide both sides by tangent of 32, right? That's going to go to 1. So I get x equals 7 over the tangent of 32 degrees. Now, I don't have time, so I'm just going to leave it like that because we can practice typing this into a calculator, right? That's just typing it into a calculator. So that's it for today, everybody.